Our next one's a little bit harder. What we have is rational exponent. And whenever we have a rational exponent, it's going to be a little bit more difficult. So again, first thing we have to do, we are looking for the extrema over this closed interval. So we need to first figure out what are our critical numbers. Critical numbers, we got to first differentiate. So let's go ahead and find the derivative. We get 2 minus 2/3 comes down, which ends up giving us 3. Oh, I lied. Gives us 2 x to the negative 1/3. Okay. Well, here's the problem. We can't just figure out what makes this 0 off the top by looking at it. So we're going to have to do a little work. First thing, I'm going to rewrite this as x to the 1/3 in the denominator. Now that I have that, I can go ahead and try and figure out common denominators. Well, common denominator is just going to be x to the 1/3. So I'm going to multiply that by x to the 1/3 and this x to the 1/3. Now what we get is 2x to the 1/3 power minus 2 over x to the 1/3. Now remember what a critical number is. It's where the derivative equals 0, which we're going to solve for in a second, but also where the derivative does not exist. We have a value in the denominator, so that value there, we know that the value that x can't be is 0. So our first critical number is x equals 0. Again, because if we put 0 in the denominator, we get undefined, and that tells us the derivative does not exist there. The next one, a fraction can only equal 0 when the numerator equals 0. So all we really have to do is solve the numerator for 0. So I can go ahead and add 2, divide by 2, which really just gives me 1. And then I can cube both sides. So x equals 1 is again our critical number. Well, just like in the last one, we're going to go ahead and make a table. Our 0 and our 1 will go on, and both of our endpoints. And remember, we're plugging this into our original function. And it doesn't always work out pretty with these. Negative 1's not too bad. We plug negative 1 in, and we get negative 5. We plug 0 in, we still get 0. If we plug 1 in, we still get negative 1. That's pretty good. But then you get here, you get 2 times 3 minus 3 times 3 to the 2/3 power. Well, that doesn't work out too great. We get 6 minus 3. Remember, this is the cube root of 3 squared. Now, if you estimate this, you get cube root of 9. Well, 9's a little more than 8. We know the cube root of 8 is 2, so this is a little bit more than 2. 3 times a little more than 2 is going to be a little more than 6, so this is going to give us a negative decimal. And if we were actually going to try and figure out what that was, it would be like negative 0.24, but we don't use calculators, so we just kind of leave it like this. But again, it's not going to make a difference because it's not our least, it's not our greatest. Our least is going to be negative 1.5. So our minimum is going to be negative 1, negative 5. And our maximum is actually going to be the 0, 0. Okay, because we know this is going to be negative and it's going to be a little less than 0, not too far down. Okay, so this is what we have to do when we end up getting a fraction as a derivative.